What's up guys? In today's video I'm going to explain you what are logical gates and how to use them in Java. But also I'm going to explain you what are if statements and how to use them in Java. So a logical gate is basically a component or a software component in which you have several inputs and then you have another output, and depending on the value of the input you have one output or another. So look, we have these ones which are the AND gate, the OR gate, and the NOT gate. There are more, but these are the most used ones in programming. So how does the AND gate work? For example, in this schema we have 2 inputs and 1 output, but we could have 10 inputs and 1 output, or 20 inputs and 1 output. The thing about this gate is that in order to have a 1 in the output, we need to have all the inputs to be 1. So for example, here, only when A and B, which are the inputs, are 1, we are going to have in the output a 1. But in any other case, for example, here A is 1 but B is not 1, but here B is 1 but 0, but A is not 1, so then the output is not 1. But only when remember, all the inputs are 1, we are going to have a 1 in the output. I want you to know that it's when they are all, because we may have here C, D, E, we may have more inputs, so remember that it is only when all are 1. But then how does the OR gate work? In this case, we only need one of the inputs to be 1. So for example, here, when A or B is 1, we will have in the output a 1. So for example, here B is 1, so we have a 1. Here A is 1, so we have a 1. And here A and B are 1, so we have a 1 only when we have one of the inputs to be 1. Like, we don't mind if it is A or it is B, but it's just one of them. Then we have the NOT gate, which has only one input, and basically it negates, it changes the input sign. So for example, we are receiving here a 0 and it gives us as an output a 1, and here we are receiving here a 1 and it gives us as an output a 0. You just also have to know that usually 0 refers to false and 1 refers to true. So for example, if we have two, I don't know, sentences, and if we are using the OR gate, the entire sentence is going to be okay only if A and B, both sentences, are true. Well, no, in the OR gate, when one is true, like A or B is true. But let's go see how this works in Java. So this was the previous video, and now what we are going to do is that we are going to create several variables, like for example int A equals 0, and we are also going to create a B variable equal to 1. So in order to create an if statement in Java, we just simply have to put here if, we open the brackets, and now we have to put the comparison or whatever we want to do inside here. So for example, we want to compare A and B, and we want to say, is A equal then B? So is A equal then B? In the case it is true, we are going to print system.out print line they are equal. But in case they are not equal, we are going to print, well, in any other case, which is like else means that in any other case, we are going to print system out print line they are not equal. So how does the if work? Remember, you just have to put here if, then you open the brackets, then you put the condition inside, then you open curly brackets, and inside the curly brackets you put whatever you want to do if the condition is accomplished. So if this condition is accomplished, we are going to print they are equal. In any other case, which is the meaning of else, we are going to print they are not equal. So now, if we compile this test.java test, they are not equal because A is 0 and B is 1. But if we put this, now it is going to say that they are equal because they are equal. But Kevin, you explained logical gates, and here we are just simply checking one sentence. So for example, this is just one input. This would be just A. So how do we apply logical gates in Java? For example, now let's apply the AND logical gate. And for that, we put this. This is the meaning of AND. And yeah, for example, let's say that we want to print this message only if A and B are equal and also A is bigger than 2. So now we have two inputs, like the first sentence is saying, is A equal to B? And the second sentence is saying, is A bigger than 2? So only if both conditions are accomplished, we are going to print this. So remember that the AND operator works only when both things, well, all the inputs are okay, like are true. And in any other case, we are not going to print this. Let's change this message. They are equal and A is bigger than 2. And here, let's say that they are not equal or A is not bigger than 2. Why am I saying here or? Because if A is equal to B but A is not less than 2, then it will not work. But also it will not work if A is bigger than 2 and A is equal to E and A is not equal to B. So for example, let's execute this, and in this case, you see that they are not equal or A is not bigger than 2. They are equal in this case, but A is not bigger than 2. So for example, now let's do this 3 and let's leave it like this. In this case, it won't work as well. Why? Because A is 3, these are different. Yeah, this condition is accomplished, A is bigger than 2, but A and B are not equal. So for example, let's continue and now let's make this work. And in order to do that, we put this. And yeah, they are equal and A is bigger than 2. But we can do more things. We can use the OR gate. And remember that in the OR gate, we just need that one of these inputs is okay. So let's say that A is bigger than 2, but they are different. So then this condition is not accomplished, but this one it is. And as we said in logical gates, when we have any of the inputs to be 1, to be true, then it will work. So now we are saying they are equal or A is bigger than 2. And if it doesn't work, it means that both of the conditions are 0. So they are not equal and A is not bigger than 2. So for example, if we try to execute now, we know that they are not equal and it prints this first message, like it is okay. And if we now put, for example, 1, they are equal, but A is smaller than B, than 2, sorry. But as we said before, we have one condition being accomplished. So that's why it works. But if we put here this, none of the conditions are accomplished, so it will go to this message. So then it works like that. So remember, this is the OR gate and this is the AND gate. But how do we make this to be true? Using the NOT gate, because remember that if we, in the NOT gate, we receive something false, we will transform it to something true. And if we receive something true, we will transform it to something false. So remember that now we have that A is equal to 0 and B is equal to 1. So this condition is not fulfilled. And also this one is not fulfilled. So remember that the NOT gate only receives one input. So what we can do is that we can take the entire sentence, which is A is equal to B and A is bigger than 2, and say that if not this, which means if this is false, we are going to transform it to true, and then if the transformation result is true, then we are going to print this message. In any other case, we are not going to print this. So let's change the message, and we are seeing now that they are equal, or A is bigger than 2, and well, let's just print here true and here false. So now, if we compile and we execute, we see that we get true, but look, A is equal to 0 and B is equal to 1, so this is false, and A is 0, so is smaller than 2, so this is also false. So the result of this is false, but we are using the NOT gate and we are transforming false into true, and that's why here we have true. And for example, we can do this in the OR gate, and both conditions are false, so it will return false, and we have here that it will transform false into true. But what if one of the conditions is true? We are going to transform true into false. And as you can see here, we have false. So, this is everything for the... Well, no. I forgot one thing. Oh my god, I forgot one thing. So, as you can see here, this is in any other case. But what if we want to add even more conditions? So, what we can do is that we can say, well, we can use the else if. So, for example, else if. And here we can put another condition and we can say that we want to execute something else. So for example, give me just 1 second. Okay, now this is beautiful. And let's say that, okay, in case that, let's remove the not. If A is equal to B or A is, let's put the and. And now they are equal, but A is smaller than 2. And let's say that if A is bigger than, well, yeah, A is bigger than 0, what we are going to do is that we are going to print that A is bigger than 0. And I don't know why this X appeared. Let's say A is bigger than 0. So now we added a new condition, and the way Java is going to look at this is that, hey, it goes here and it checks, it says A is equal to B, yes. A is bigger than 2, no. So then, as we are using the AND operator, we cannot print this. So now it goes to the next condition and it says, is A bigger than 0? And it says, yes, okay, I'm going to execute this, and I'm going to ignore everything else. I'm just going to execute one of these things. So for example, if we try now to execute, we can see that we have A is bigger than 0. And we could add even more things. So for example, we could say here, else, let's say that here we want that A is bigger than 2, but here we want that else if B is smaller than 2. In this case, what we are going to do is that we are going to print that B is smaller than 2. So here we say that B is smaller than 2. And as you can see here now, well, as you are going to see now, this message is the one that is going to be shown. So B is smaller than 2. That's what we have. Another thing is that in one program we can have several ifs, because now, as you can see, we are going to execute one of these things. But what if we want more ifs? So for example, we want to have 2 things executed. Well, you can put more things here, but what I mean is that sometimes just one if isn't enough and you need more. So for example, here what you can do is that you can put here if, I don't know, let's create another variable. Say that B1 is equal 1 and B2 is equal 3, and we can now say if B1 is different than B2, then print system out print line print b1 is different than b2. And as you can see here, this is the symbol of different. Like you can use several symbols. For example, this is bigger than, bigger or equal than, this is smaller than, smaller or equal than, and there are even more. So if we compile this and we execute, we see that from this first, let's come here, from this first if we have that b is smaller than 2, but from this second if that it only has this, we have b1 is different than b2. But for example, let's say this, and if we now execute here, compile and execute, we have the first message, but this condition here is not fulfilled. So we do anything because we didn't define that in any other case. What do we want to do? We didn't define that. But what we can do is that if this is different, well, we can use the not gate, and now it will work. b1 is different than b2, which is, this is false, but yeah, what we can say is that b1 is equal. So yeah, now this is everything for ifs and logical gates in Java. I hope you understood that. I hope you now know how to use the if statement in Java, and if so, give it a like, share, subscribe, and see you in the next one.
Ay.